All right, gang, stat 1150. The two previous videos have just gotten us to the point where we're ready now to start working hypothesis testing problems. And again, I'm going to be a little bit redundant here, but all we're focusing on now is hypothesis testing for means. Next week, we get into hypothesis testing for proportions. And you're going to find it to be a lot easier because you're going to have a foundation from the means to build on the proportion problems. But the purpose of this video is to illustrate the p-value approach. Now again, there's two approaches. One's called a p-value approach, one's called a critical value approach. The next video is going to illustrate the critical value approach. This one focuses only on the p-value approach. So the example I'm going to use as an illustration says that 10 randomly selected people went on an Atkins diet for a month. Guys, I've done this diet, and it's actually, at least it was very effective for me and my wife. We went on this crazy exercise plan and diet and got and lost a lot of weight. So anyway, the weight losses for these 10 people were 3, 8, 10, 0, 4, and so on and so forth. A local dietitian claims that people using the Atkins diet will lose an average of 3 pounds in the first month. Using a significance level of 0.05, we'd like to test her claim. Now, as you're reading these problems, you need to look for the buzzwords. Notice it doesn't say we'd like to test the claim to see if the average weight loss is more than 3 pounds. It doesn't say we'd like to test the claim to see if the average weight loss is less than 3 pounds, more than 3 pounds. It just says test the claim. So what you should think from this is, in the alternative hypothesis, we're going to have a two-tailed test. We're going to have a not equal to. And again, I taught the two-tailed test and the not equal to in the previous two videos. All right, let's get our hands dirty. What's the population under investigation? Well, that's pretty simple. It's all people who use the Atkins diet for 1 month. What is the sample we'll use to investigate the population? Now that's these 10 subjects. Subject 1, Subject 2, Subject 10. Okay? First thing I want to do is I want to calculate the mean and the standard deviation for the sample, and I want to compare the mean to the dietitian's claim. So guys, what I've done, I've already gone over here on Google Chrome. Oh, oops, I already had it up there. And I typed in the 10 measurements, and I reset the heading to be weight loss, and I typed those in very carefully. And went to stat, went to summary stat, went to columns, clicked weight loss, and then I wanted the mean and the standard deviation. So the mean is 4.6, and the standard deviation is 2.95. Now, guys, it's important that you understand that this mean is X bar, and this standard deviation, oh shoot, I think I got that wrong, 4.6 and 2.95. Okay, so that's describing our sample, right? So it's tempting to look at that 4.6 and see that it's bigger than the 3 and conclude that the weight loss program must be better than the dietitian is making the claim about. But guys, you got to remember, this is a sample mean. This is a population mean. And is that 4.6 far enough away from the 3 to conclude that the 3 is incorrect? Or is the 4.6 close enough to the 3 to believe that the 3 is correct? Guys, we expect samples to vary. We expect this 4.6 for 10 people maybe to be a 3.8 for the next 10, or a 4.2 for the next 10, or a 2.8 for the next 10. We expect these to vary. But what we're going to do, we're going to use this in the context of the central limit theorem to see how far away in standard errors that this value is from that claim, in essence comparing it to our line in the sand that we'll establish here in just a second. D, does the distribution appear to come from a normal distribution? Well, guys, one of our conditions is what? We must have a sample size of 25 or more, or we must know that our population is normally distributed. Well, what takes care of that in this problem is this statement right here. We'll assume the distribution of all weight losses on the Atkins diet is normal. So we don't need the sample size to be 25 or bigger because we have a normal distribution. So one of the conditions is satisfied. All right, guys, now we're going to get our hands dirty. We're going to conduct the test of hypothesis using the p-value approach. There are 4 parts. State the appropriate null and alternative hypothesis. Guys, remember, the null hypothesis is H sub O, colon, the parameter value, in this case, of the dietitian's claim. The alternative hypothesis is H sub A. This letter always comes here. This value always comes here. And then we choose a competing inequality to represent the way the problem is laid out. Well, as I talked about earlier, it just says test the claim, not because it's higher, not because it's lower, just test it. So what we're going to have right here is not equal to. So guys, we are conducting a two-tailed test. If you don't know why, then you need to rewatch the second video. Part B, choose the significance level, the test statistic, and the condition. Significance level is what? Let's go back to the original problem. Use significance level 0.05. Now, what do we know from this? That our alpha is 0.05. Test statistic. Because we are testing a value of a mean, we know we're going to use a t-test. Again, that's from the previous video. So we're going to calculate a t-statistic or a t-value. Conditions. What were the conditions? Normal or n greater than or equal to 25. Random. That's the second condition. And 3, independence. This is true. The way the problem is laid out, we have randomly selected 10 subjects, and we're going to assume that we have independence. C, compute the test statistic and the p-value. Well, guys, I'm going to use StatCrunch to calculate these two things. Our t-value and our p-value. So guys, I'm going to go over here. And I'm going to go to Stat, T-Stats, one sample with data. So I've got my data in weight loss. I want a hypothesis test for mu. I want mu equal to 3. Notice the choices I have here. Less than, greater than, not equal to. We want not equal to. And it didn't even let you screw up here. When you put a 3 there, it forces a 3 here. You have H sub O, it forces that. So guys, just as I've taught before, the thing you have to choose which inequality represents the nature of the test that you're conducting. All right, come on down. All this stuff is cool. You know, it does stuff. We don't need it. So we're going to hit compute, and we're going to very, very quickly get our answer. So our T-stat right out here is, we can see it, that's our test statistic, and that's 1.71. So I'm going to write that down so I don't forget it. And our p-value is 0.12. So again, our t-value is 1.71. We can see that we have a degrees of freedom 9. Our standard error, if we took the standard deviation divided by the square root of 10, our sample size, this is what we would get. And this is our sample mean. So, all right. So again, test statistic 1.71, p-value 0.12. So I've written that over here. Now, what does this tell us, this 1.71? This tells us that our sample is 1.71 standard errors above the claim in H sub O. What's the claim in H sub O? Mu is equal to 3. So our sample is 1.71 standard deviation, standard errors, above the claim in H sub O, which is the mean is equal to 3. P-value 0.12. If the null is true, the mean truly is 3, then there is a 0.12 probability of attaining a sample mean this extreme. So that's interpretation. So ultimately, guys, what's going on here is we have our distribution of sample means. Smack dab in the center is the claim from the null hypothesis. We got a sample mean equal to 4.6. This distance from the claim up to our sample is 1.71. I think I got that right, standard errors. Now, is that close enough to say, well, seems like it's 3? Or is that too far away to say, well, it seems higher than 3? Well, you got to establish your line in the sand, and your line in the sand is your level of significance. Which brings us to the, let me find a sheet of paper here, boys and girls. Brings us to the, so we've stated the appropriate hypotheses. We've chosen the significance level, test statistic, and checked the conditions. We've computed the test statistic and the p-value. The test statistic's the t-value, it's 1.71. Our p-value is 0.12. And the final thing we do is interpret. Should you reject or fail to reject? Well, guys, remember the whole reject thing from the previous video. If our p-value is less than alpha, then we reject. And guys, we fail to reject and reject H sub O. So our p-value was what? 0.12. Our alpha, we established back at the beginning of the problem, was 0.05. How does 0.12 compare to 0.05? What's greater than or equal, isn't it? So we come up, we decide that our final decision is failed to reject. Fail to reject, easy for you to say. H sub O. Indicating there is insufficient evidence to conclude that the mean weight loss is different than the 3 pounds that the dietitian made the claim. P-value is higher than the line in the sand. Now, if this p-value had been less than the line in the sand, we would have rejected H sub O, and we would have found that there is sufficient evidence to conclude that the mean weight loss is different than 3 pounds. Now, what I always like to do is follow this up with a confidence interval. And because we had 0.05, we're going to calculate a 95% confidence interval. Now, guys, I want you to tell me, just think it through. Should 3 be in our level? Should 3 be in our confidence interval? Well, we didn't reject it, right? So you would think that 3, it would make sense, statistical sense, and really a little bit of common sense, intuitively speaking, that 3 is going to be contained in our interval, right? Because otherwise, we would have rejected. So let's go get the confidence interval and take a look at it. So let's work the same way. Go to stat, go to tstat, one sample with data. But guys, this time we're going to come down to our confidence interval from you. Hit compute. Well, we should tell where the data is, shouldn't we? And our left limit is 2.49. And our right limit is 6.71. Notice that 3 is contained in there, which kind of validates the fact that we did not reject that claim. All right, second page, just follow up a few questions. State an appropriate conclusion. We've already done that. Okay. Calculate a confidence interval using the appropriate level. We did that. What was it? 2.49 to 6.71. And mu equal 3 is contained in this interval, which well, I didn't complete this, did it? Does the confidence interval validate? What it does, because it's contained in there, so it supports the decision from the test of hypothesis. Now, it's not always going to do that. In fact, I'll put up one complete video to show you conditions where the conclusion we get from the null hypothesis contradicts and conflicts what we get from the test of hypothesis. So the confidence interval and the test of hypothesis are conflicting. But for right now, we're not going to go there just yet. Now we're going to end this video. So guys, in preparing for the next video, go ahead and print out the. It's the same problem, but we're going to do it instead of the p-value approach. We're going to use the critical value approach. Take care.